As I already told you, very important topics were covered in last lecture, and only a couple of people had joined the session. So uh, I'm just gonna run through the topics we covered previously, and then we resume. So, okay, let's start with a few question and answers because I want to understand how much of you really understand it. Okay, I did the same during the last session as well. Okay, so can you guys frame a few examples of embedded system and give me a definition in your language, like according to you, what is embedded system? What is your understanding of the system so far? Anyone?
So an embedded system is a specified computing system that is designed to perform dedicated functions. Like example, microcontroller and sensors, display, software.
What is this example? Like, what is microcontroller? You mean microcontroller is an embedded system?
Yeah, microcontroller it is a embedded system.
Uh, I wouldn't say that. See, microcontroller is something that is controlling the whole thing, right? Like the system is built around the microcontroller. Microcontroller in itself is not an embedded system. So, say there is a controller, okay? There are input devices connected to the controller, and there is output coming out of it, okay? And the output could be actuators, inputs as sensors. So this whole system is an embedded system. Okay. Input output devices including that controller. So that is embedded system. Okay. Uh, Basically a system having microcontroller or microprocessor, one or multiple, okay, designed to perform constituent task in a larger entity is embedded system. Okay. So, example could be anything from a smaller piece of your mobile phone. Okay, I wouldn't say mobile phone is an embedded system. Mobile phone is an entity. There are small systems under that mobile phone. Those are embedded systems. A car running on road. I would say car is not an embedded system. Okay,
Airbag systems.
yeah, but there are smaller systems inside of those that car. Okay, those are embedded systems like the instrument cluster. Okay, then we have infotainment system. Then we have MP3 players. There is speaker. There are a lot of things. Okay, another example of embedded system is smart speakers. Now, what do I mean by smart speaker? Anyone? You must be using those in your daily life. Smart speakers.
Like Alexa.
Alexa, right? Got my point. So this is embedded system basically. So we are gonna learn. So for rest of the guys who don't have any context, like we started with security, right? Embedded security, but knowing that most of you are not aware what embedded system in itself is, we are moving on with the subject embedded system engineering, and next semester we will learn security. Okay, so in embedded system engineering, this is the basic. Like I mean, you all have been through the types and definition. Now we are moving much deeper into the syllabus with architecture, pin configuration of a basic microcontroller. Okay, so this microcontroller I'm gonna talk about today is the 805. It's the base of all the series. Okay, so if you understand this pin configuration, you can relate it with the other controllers as well. There is no difference as such into them. Okay, if there are some things that are changing here and there features wise, like if I'm saying My controller is having 2 KB of RAM, then the other might have 4. Okay, but nothing apart from that functionality wise changes until and unless there is a huge update. Like I'm telling you, a microcontroller 8051, and you are talking about ARM and Cortex Smart, those advanced processors. Okay, that is different topic. Advanced processors. We are talking about controllers and embedded systems. Okay, to understand the difference between two. Next thing we talked about was like difference between controller and processor. So anyone out of you would be able to tell me that? Okay, what do you mean by controller? So like, okay, forget about the controller, processor. So you're buying a phone, you're buying a laptop, you're buying a computer. First thing comes to your head is how much is the RAM, how much is the storage, how much is the processor, right? So what is that processor? Tell me that. No idea. Processor controller, guys. Processor controller. We repeated it a very like numerous number of times. So I expect response from you so that I know you understand it. Right? Because things are very much dependent on it going forward, and I don't want you to be with blank slate. The whole reason why we changed the whole subject, we wanted to be embedded system engineering, not security in the first. So the intention is you understand, and then we, move further. So you want me to explain? Tell me. That so I'll do that. You just don't sit like this quiet in front of me. Just speak up, whatever it is. No. So, mm, okay, I'll ask you a few questions, short questions. Okay, which is faster, processor or controller? Which one is faster?
Processor.
Processor. Why? Why is it faster?
Uh, because it serves as a brain of the device, interpreting and executing program instructions from software to other inputs.
Okay. The reason behind it being fast is it has that kind of resource support. Okay, and it operates at very high frequency. Okay, very high frequency. Like you, when you go to buy a processor, you check, right. It is written in gigahertz, right? Always gigahertz for laptops, whereas microcontroller frequency is very less. Okay, the frequency it operates at depends on the crystal. Okay, the crystal that we are connecting to it. We talked about crystal a lot in last lecture, and I'll talk about it here again. Okay, so this crystal, do you remember these pins I'm writing here? So this is the crystal that you know gives in the frequency and stuff to the controller. And so basically processor is designed to perform okay, tons of tasks. Microcontroller is designed to do single task, okay, single or dedicated task, I would say, okay. Hmm. Whereas processor it performs a lot of tasks, okay. Again, this is costly option. This is cheap for obvious reasons. Now, what is happening here? We have a processor, we have a controller. So, processor, तुम लोग लैपटॉप लेने गए हो तो you ask for RAM, ROM, right? So everything is connected externally. Okay. In controller, everything is inbuilt. Okay. If this is your controller, chip 40 pin package like we studied the last time. Okay. It is having processor in it. It is having RAM. It is having ROM. Everything. Okay. So it is included in it. Got it? So these are the basic differences. I don't want you to be blank in the next lecture, guys. Otherwise, I can't move on. You're not understanding my point. So, okay, at least do you understand now when I explained it again?
Yes, sir.
Okay. We also went through the types. Okay, I'm not running through the types again. Now, you'll have to go through recordings and stuff. Then we saw introduction of RTOS. RTOS is basically real-time operating system. It's designed for providing a deterministic and predictable response. Uh, for task execution. So that's why we use RTOS. Normal embedded systems are there in picture. Okay, normal controller won't have this RTOS as an operating system in it, but why we primarily use it, it's for deterministic and predictive response. Okay, and the key characteristic itself is like predictable response time and priority. Okay, priority handling. So we set the priority according to which it handles it, and the time response is something that is very special about RTOS, and that's what we talked about in earlier lectures. So then we saw a difference between general purpose OS and RTOS. General purpose OS is designed for multitasking and minimizing resource utilization, right? But RTOS, on the other hand, no. RTOS is for real-time constraints and predictable performances, not for multitasking. Then task scheduling, task priority, latency, these are more characteristics. Then importance is basically like deterministic behavior, resource management, and reliability and stability. That is what we are having in place with the help of RTOS. So this is what the RTOS. Then the architecture. Now, uh, let me paste a simple architecture here. Can you see, what can you see? Would you guys be able to confirm? Would anyone be able to confirm? Because I already see your cameras are off. So I don't know if you're there. What can you see on the screen? If you're
So
talking, you're
there is diagram.
okay. And uh, can you see what I'm writing on it?
No, sir.
No. Okay. Okay. So even in the earlier board, you must not be able to see, right? I have written the differences and all. Okay. Anyways,
So
I'll
that was visible, sir. The
okay.
difference between microprocessor and microcontroller.
Okay. Fine. Thanks for confirming. I'll launch my board in the system. This is Teams shared board. Okay, you can also contribute on this whiteboard. You can also write. If you see, your names are listed up here. When if you start writing, it will actually write on this board, shared board. See, somebody has moved this image. You can also contribute.
Yes, sir, I did.
Okay, so I'm sharing the other screen right now so that you can actually see what is happening. So confirm me, what do you see here? Now I'll quickly go through the diagram. I'll basically tell you what is this. So this is architecture, okay? Let's say 8051, okay? Again, I'm not giving specific number, just for reference. It's just for reference, okay? If you know this, then you know the processors and controllers better, okay? That's the only reason I'm talking about this series, okay? 8051. So the basic architecture of any microcontroller would look something like this, okay? It's having CPU in place, okay? CPU. And what is CPU, guys? CPU is something which is controlling everything, and it is a digital device, okay? Digital electronic device. What it is? Digital electronic device. When I say that, I essentially mean it operates on clock cycles or clock signal, whatever. And who is giving this clock signal? OSC. What is this OSC? This is oscillator circuit. Okay. Now, since you are not from electronics background, I'm just gonna give you a quick brief about oscillators. Oscillators are circuit which are generating this kind of signal at the output. Okay, just remember that with respect to time. Okay, what is oscillator doing? It's generating this. Okay, then what is this? This is crystal. This crystal is this is a crystal. Okay, and it works on what? Piezoelectric principle, which says that provided electrical vibrations to the crystal, it gives us mechanical vibration, and vice versa. If we provide mechanical vibrations, it gives us electrical response. So this is the magic of this crystal. Okay. So using this piezoelectric principle, what we do is we generate particular frequency at the input of this oscillator so that it generates proper pulse or proper signal for our CPU to work. Understood till here? ये जो क्रिस्टल है ये एक फ्रीक्वेंसी जनरेट कर रहा है, and this oscillator is regulating that and generating a constant wave in the input of the CPU, and this is the signal CPU is operating at. Okay, CPU needs this signal. Okay, now going forward you're also going to write codes for the square wave generation, signal generator, output generator using controller. So we are going to consume the same frequency to generate those signals because we already have frequency. We're gonna count a number that we are gonna load to a timer, generate a delay, and generate a constant response at the output. So is what we want to do in a few of the future sessions. So that is where this frequency is very important. Okay, so is this part clear? Are these two sections clear to you guys? Why oscillator is there? Why crystal is there? Why CPU is there? Are you following me with this? Yes or no? Simple answer. Not expecting anything more. Please. Yes.
So can you repeat, please?
I didn't get you.
So can you please repeat?
Okay. So CPU, you know what is CPU, right? CPU is an electronic device, right? It is an electronic device, which is digital in nature. Okay. When I say CPU is a digital electronic device, okay. So you guys have idea how digital devices operate? It operates on 0 0 1 1 1 0 0 0 1 0 1 signal like this. There are two signals, analog and digital. Do you at least know this?
Yes, sir.
Okay. So this is digital device which will operate on this and not on analog signal, okay, which is constantly changing with time. So understood till here. CPU का function तो तुम लोगों को पता है. Okay, I need not explain that why CPU is there in place. But I'm bringing the relevance of this circuit in place here. That's why I'm talking about CPU. So what is oscillator doing here? Okay, CPU को एक सिग्नल चाहिए ऑपरेट करने के लिए, वो किससे मिल रहा है? ऑसिलेटर से मिल रहा है. ठीक है, ऑसिलेटर के आउटपुट में हमें ये मिल रहा है. ठीक है, एंड what is input of oscillator? This crystal. Okay, this could be any crystal found. Okay, any crystal, and all the crystals, okay, all the crystals have this piezoelectric principle which it works on. Okay, so what does this say? Okay, when you give electrical signal to these crystals, it is gonna vibrate mechanically, okay? Mechanical vibrations. And vice versa, okay? If you provide mechanical vibrations, it will give you electrical signal, okay? So using this principle, we are generating a frequency at the output of crystal and then the input of the oscillator, okay? And this frequency is regulated further by oscillator and given to CPU as an input, okay? So you will understand this thing much better when you go through the last lecture and the block diagram thing. I'm still gonna cover block diagram, but not in so many details, okay? So block diagram में मैंने बताया है properly. So ये जो crystal है ये कंट्रोलर की ब्लॉक डायग्राम में आपको दिखेगा क्योंकि वी हैव टू कनेक्ट इट we need that frequency for operation, right? We need this signal basically. And okay, remember this in shortcut, we need this signal and that's why we are using this circuit, okay? This part of the circuit. Okay, now is it clear to you, or you want me to explain further?
No, sir, it's clear.
Okay, fine. It's a simple architecture, okay? Try to understand parts of it, and if you are understanding meaning, at least what it does, okay? Rest leave on me. So now let's talk about okay, ports. Let's go step by step. So what is this? Four input output ports. Hmm. So every controller, okay, every controller has some pins, okay? तुम लोगों ने आईसी देखी होगी, नॉर्मल आईसी, कॉलेज में आईसी देखी है, उसके से पिन्स होता है. तो that is nothing but input output ports, okay? So these pins, suppose my controller is 40 pin ka controller, okay? Then these pins are divided into four groups, and this is called four ports, input output ports, okay? Input output ports means these 8 pins is my, let's say, port 0, port 1, port 2, port 3, whatever is the convention, okay? Just for reference, this is. So this is how these four ports are, okay? And these are called input output ports, bidirectional input output ports. Okay, understood. So this is nothing but input output port. So there might be some sensors connected to it for some system. There might be some actuators connected to it for output, generating output. Okay. So inside of our controller, we have memory. Okay, we have data. We have a code which is at some memory location. What is happening around all this? Okay, there is a data flow. Okay, there is a code written at some memory location in our controller chip. Okay, so there should be address and data buses in it, right? In address buses, address, I mean location of the memory will flow. In data buses, the actual data flow will take place. So you can consider these things, okay? These things are nothing but address buses and data buses, okay? and this is bus control, basically, which thing to accept at the moment, if it is data, if it is address, if it's multiplexed, if it's different, if it's demultiplexed. So everything bus control will happen using this. Okay, data and address thing separation will data and address. Okay, data flows in data bus, address flows in address bus. Okay, some controllers have them combined, that is called multiplexed signal. Okay, so again the separation and all that will be taken care by bus control. Easy, right? So after that, what else do you see on this diagram is on chip ROM. Okay, now can anyone tell me what is program memory and what is data memory? Come on.
ROM is program memory and RAM is data memory.
Okay, okay. Can you tell me again which out of these two is RAM? RAM, RAM.
Data memory.
Data memory is RAM, right? This is wrong. So what happens? Our controller is having on-chip ROM and RAM. Okay, on-chip RAM and on-chip ROM. So this is nothing but that. Okay, so we need ROM to store our program. Okay, remember using this. Program is ROM, of course. Data is data flow RAM. That is RAM. So we need both of them. In controller, we have to connect them differently from externally, whereas in microcontroller, it is on chip. Okay, at the same time, you have it on your chip. That's why it is on chip. On chip ROM, on chip RAM. So if I talk about basic series, so it has something like 2 KB of RAM and 128 bytes of ROM. Okay. Now, do you know how much like this KB bytes conversion you must be knowing, right? 1 KB is how many bytes and stuff like that, you know, right? 1 MB is how many KBs? Do you know that? Guys,
Yes,
you
sir.
there? Okay, thank you for the information. So it's that small, okay. Our code is into bytes. It needs RAM, okay, because there are a lot of registers it has. So this part is almost done. I'll keep it here. Now what we have now left is timers. Okay, very interesting section. Timers and counters. So T0 and T1. What are timers basically? So when we are counting events, okay, generating delays, when we are doing when we are generating signals at the output, or when we need what else, timer के applications क्या हो सकता है. So we are dealing with some time sensitive task. So that's when the timers come into the play. Okay. Timer is very obvious. I need not explain much. It is a timer basically, normal time. The serial port. Okay. So four input output ports I talked about earlier. Okay. Four input output ports. So all four are parallel ports. Okay. And there is one, TXD and RXD pin. Okay. TXD and RXD means this is transmission and this is reception. Okay. And how it is happening? It is happening serially. Okay. Rest all is happening parallelly. So this is about it. So is timer, serial port. Mhm. Okay. And this is interrupt control. This is the part which is left now. So what is interrupt? So suppose my controller is running some XYZ code or XYZ codes. Okay, this is my primary code. Okay, the execution is going on like this. But what I'm saying is at this particular time or when a user is pressing the key, give the signal to output port to open the door, or when a person existence is detected in a room, ring an alarm at the output port. What is this? This is interrupt, right? Normal execution is going on of home automation system ka code. Okay, and here achanak se there is a presence detected. Okay, this is, I'm giving you example of a system. It could be anything. Interrupt could be anything that we configure as an interrupt in my home automation system. When I'm not home, I mean if a person's presence is detected, that is an interrupt. इंटरप्ट डिटेक्ट हो गया तो ये एग्जीक्यूशन स्टॉप हो जाता है एंड इधर से आगे रन कौन सा कोड होता है, अलग कोड रन होता है जिसको हम क्या बोलते हैं, ISR मतलब इंटरप्ट सर्विस रूटीन. सो इसका एक अलग से कोड लिखा होता है हाउ टू हैंडल दिस इंटरप्ट. once this is handled once this is handled, what happens? Shit. Okay. Once this is handled, the control again goes back where it stopped. Okay, and it again starts to run from here. Okay, again it continues. So the thing, but interrupt handling, interrupt control. Okay, so this handing over the control to interrupt service routine and taking it back. This is nothing but interrupt control. So this is also very important. Did you understand what interrupt, guys? What is interrupt and stuff? Interrupt समझ में आए क्या? Like what is interrupt at least, and why do we need them? I assume yes. Okay. So after this, I'm gonna start with the block diagram. Okay, quick revision thing, and then we are talking about few registers. Okay, the basics of registers, why they are in place, and few registers that you might already know, but I'll still go through. So before we go there, I would like us to have a short break. It's 8:04. Okay, let's be back by 8:12, maybe at 12:15. Okay, let me know if you are here or you are gone for the break already. Are you guys there?
Yes, sir.
Yes, sir.
How will I know? How many times should I say? Anyways. Hey guys, are you back?
Yes, sir.
Okay. May I see your happy
Yes, sir.
face again if you are awake now? Okay, so interrupt समझ में आया guys? Interrupt क्या है? How? Why do we have interrupt control? Okay, so good. समझ में आ गया interrupt? Guys, I want to hear from you. Do you guys understand? Did you understand interrupt?
The interrupt is something that pause the current execution.
It is in normal term. It's like, see, you're talking, somebody has interrupted you, okay? You attended that person and you again started talking. This is interrupt. Okay, you're
Yes.
doing your task, something comes in between, then you move on to that task, you complete it, and you again go back to your task. This is interrupt handling, okay? Anyways, I'm doing everything. Let me share my screen for something else now, which you should tell me now. ये लास्ट लेक्चर में कौन था बताओ मुझे. Who all were there during the last lecture? Only a couple of people, I guess. So what do you see on my screen right now? स्क्रीन पे क्या दिख रहा है?
The pin diagram.
Pin diagram. Thank you. So yes, this is pin diagram. I'll explain quickly, okay? All the pins because we already done this part of the syllabus. VCC ground first of all. Okay, this is our 8051 का 40 pin वाला controller. Okay, 40 pin का DIP package बोलते हैं इसको. DIP. DIP is nothing but dual inline. Okay, because there are two lines. Some packages are like this. चारों तरफ pins रहते हैं. This is dual inline package. Okay, this is different. So VCC, of course, will be connected to VCC power supply. Okay, whatever it is. Ground is of course connected to ground. Okay. Now port 0. Port 0 क्या है? General purpose input output, which is bi-directional general purpose input output port. Okay, means it is accepting the input as well as it can be used as output port. Okay, what is this AD0 to AD7? So uh, as you all know that our controller is having internal ROM and internal RAM, okay? But sometimes the code is so big that it cannot be fit into this particular internal ROM. So what we are gonna do is we are gonna connect external memory, okay? External memory, okay? So this external memory interfacing happens, and the address of this memory is 16-bit address, okay? 16 bits address. So उसके लोअर 8 बिट्स इधर से हैंडल होते हैं, हायर 8 बिट्स इधर से हैंडल होते हैं. Are you understanding now what is AD0? मतलब this is multi-purpose port. It is general purpose input output bi-directional port, as well as it is handling the lower 8 bits of external memory address. एक्सटर्नल मेमोरी के एड्रेस को हैंडल कर रहा है ये पिन, ओके, ये कोड. आफ्टर दैट यू सी EA bar slash VBB. So these are active low pins, okay, active low pins. EA is enable access, okay, enable access. अभी किस चीज का access? Again it is related to external memory, so it enables the access of external memory when it is given VPP supply. I'm sorry, when it is giving power supply, okay, it connects the controller to external memory, okay, and when it is grounded, it is acting as a normal, okay. Then alien program bar. ALE is nothing but enable address latch, okay, address latch. Now what is this latch? So external memory है, इसका एक part है latch, ऐसे समझो अभी, okay. Latch is nothing but holding the data for some time, okay, that is latching the data, okay. Latch का एग्जांपल एक देता हूँ, लाइव एग्जांपल. तुम कंप्यूटर पे काम कर रहे हो लेकिन किसी ने पेन ड्राइव कनेक्ट की, तो वो जो डेटा है वो क्या हो रहा है, our system is holding that data, okay. That hold is nothing but the latch, okay. So वो latch को enable करने की ये पिन है, enable latch, okay. When it is one, it will enable latch when grounded, it is for programming, okay, और उल्टा भी हो सकता है. And then PACN, तो PACN is program storage enable, okay. So external memory को program करते time we use this pin, okay, program storage enable. तो ये पिन यूज करेंगे एक्सटर्नल मेमोरी को प्रोग्राम करते वक्त, ठीक है. नाउ वी आर टॉकिंग अबाउट पोर्ट 2. पोर्ट 2 इज बाय डायरेक्शनल जनरल पर्पस इनपुट आउटपुट पोर्ट, ओके. इसमें क्या होता है, हायर बिट्स एड्रेस के हैंडल होते हैं, हायर 8 बिट्स ऑफ एक्सटर्नल मेमोरी, ओके. इधर लोअर 8 बिट्स, इधर हायर 8 बिट्स. यहां तक समझ में आ गया आपको पिन डायग्राम? Yes or no?
Yes, sir.
Yes, sir.
Okay, thank you. Okay, so now port 1. Let's talk about port 1. Port 1 is again same, bidirectional general purpose input output port. Okay. Now I would like to introduce you the new concept, okay, which is pull up register and pull down registers. Okay. Pull down registers and pull up register. So pull up and pull down register होता है. Register you know, right? This is register. So pull up register मतलब ये पोर्ट है हमारा, ठीक है, P1, जिसमें पहली पिन है पोर्ट 1.0. तो पुल अप करना है मुझे, मतलब मैं इसको एक पुल अप रजिस्टर लगाऊंगा और इधर मैं VCC दूंगा. ओके, एंड दिस इज माय कंट्रोलर. ओके, यू सी. पुल डाउन मतलब सपोज ये मेरी अनदर पिन है जो मुझे पुल डाउन करनी है, तो मैं इसको रजिस्टर लगाऊंगा और मैं पुल डाउन करूंगा. ओके, दिस इज पुल अप register and this is down register. Okay, let's pull up and pull down concept. So port 1 is internally pulled up. Okay, internally pulled up का मतलब क्या होगा कि internally इसको registers connected है VCC से. आ गया समझ में? You don't need to connect the pull up register externally, whereas पोर्ट जीरो अकेला पोर्ट है जिसको हमें एक्सटर्नली पुल अप और पुल डाउन रजिस्टर्स लगाने पड़ते हैं. आर यू फॉलोइंग मी टिल हियर? ओके, सो ये जो है ये इंटरनली पुल्ड अप है. ओके, रेस्टोलर इंटरनली पुल्ड अप, बट दिस पोर्ट जीरो इज has to be done externally, pull up, pull down, whatever operation you need. Okay, this basic thing. Then we are only left with our port 3, which is multi-purpose port in our microcontroller. Guys, you are seeing the screen, right?
Yes, sir.
Okay, so now we are talking about this port. Okay, RxD, TXD, RxD, TXD, nothing but serial transmission and reception. Serial transmission and serial reception of the data happens through here. Okay, int 0, int 1. And INT1. तो ये क्या है? दो इंटरप्ट के पिन से जो हमें एक्सटर्नल इंटरप्ट देना है, तो वो है. ठीक है, इंटरप्ट हम कोड में भी दे सकते हैं. वी कैन कॉन्फ़िगर इंटरप्ट टू अकर इनसाइड ऑफ द कोड आल्सो, राइट? बट दिस इज बेसिकली एक्सटर्नल पिंस. मोस्टली एक्सटर्नल इंटरप्ट यूज होता है. अभी एक्सटर्नल इंटरप्ट के एग्जांपल क्या हो सकते हैं कि सपोज अगर कोई रियल टाइम बेस्ड एप्लीकेशन है, सो इस टाइम पे मुझे ये करना है, सो द टाइम विल एक्ट एज एक्सटर्नल इंटरप्ट. ओके, एंड देन इट विल जंप टू इंटरप्ट सर्विस रूटीन. It will handle that and continue the regular execution. Okay, this is interrupt 0, interrupt 1, T0, T1. Now timers है हमारे पास. ठीक है, this is for timers. But timers तो internal है. ठीक है, then why the pins are there? Okay, pins किस लिए है? हमें अगर I told you that we have some set frequency that these things operate. There is a clock cycle, okay, and using that the time is calculated. Okay, so if there are certain limitations that you are coming across, okay, in order to design frequency or in order to generated delay, then what you do is you connect your own clock cycle for timer purpose. Okay, the frequency you need. Okay, whatever the frequency you need, you connect that. That is why these ports are there for. These pins are there for. Okay. Next, write bar and read bar. Okay. Read bar में होता क्या है? Again, uh, writing and reading from external memory. इसके लिए ये दो pins है. Okay, to read and write from external memory. Write bar and read bar. Now Xtile 1 and Xtile 2. Let me take it up so that you guys follow it. So you have seen this crystal thing in the architecture. So this is what it is. Okay. Then we connect it to ground. So ये basically circuit होता है इसके बाहर एक्सटर्नल 1 एक्सटर्नल 2 ये क्रिस्टल फ्रीक्वेंसी जनरेट करके इसमें डालता है इसके अंदर है एक ऑसिलेटर ओके oscillator circuit and that oscillator is connected to what CPU and this is how the cycle and of this frequency is generated okay and then ground you know this ground VCC so did you follow the pin configuration with me okay I take it as yes now let's talk about so किसी को आइडिया है रजिस्टर्स के बारे में ये रजिस्टर अलग this is REGI okay this is RESI register okay these the registers are different this is different so anybody is having any idea इसके शॉर्ट फॉर्म में इतना ही बोलते हैं so तुम लोगों ने सुना है एटलीस्ट रजिस्टर्स के बारे में पहले इंजीनियरिंग में
हाँ सर सुना
सुना है so what is it basically it is basically a memory location okay to hold the data temporarily ये सपोज मेमोरी है ठीक है so register is nothing but suppose register A register B these are names of the register on the memory how will I show this is register A this is B so this is the space for register A this space for register B okay so this is nothing but the register okay so do you guys see this one slide on my screen right now
Yes, sir.
okay so microcontroller के registers हम देखने वाले one by one after this okay so maybe not today tomorrow but these are the basic types okay general purpose registers special purpose registers and status registers okay so general purpose registers are used for various tasks like arithmetic operations data storage and address calculation so general purpose registers let's see so there are different types of registers right so general purpose register so very popular register in microcontroller is accumulator okay accumulator is a general purpose register. Okay, again 8-bit register. 8-bit register जब मैं बोलूँगा ना ये फ्रेम सामने आ जाना चाहिए 0 to 7. Okay, मतलब एट अ टाइम ये 8 बिट्स स्टोर कर सकता है. ठीक है, तो दिस जनरल पर्पस रजिस्टर. सो ये ना ऐसे ही रजिस्टर एक्यूमुलेटर को ए बोलते हैं. देन और एक रजिस्टर है बी रजिस्टर. ओके, देन देयर आर सम मोर जनरल पर्पस रजिस्टर्स. रजिस्टर बैंक्स होती है कंट्रोलर में. लाइक वी हैव R0 to R7 रजिस्टर बैंक. ओके, R0 to R7. Okay, register bank, and each of them is like this. Okay, then 0 to 7. Okay, everything is similar. 0 to 7. Okay, so this is nothing but general purpose register. Just there are memory locations, and we have designated those locations with some name so that it is easy for us to address them in order to store anything. Okay, that is the only purpose here. This is general purpose. Sorry. Then we have special purpose or dedicated. What it says, dedicated to specific functions such as controlling peripherals, example timers and UART or IC2 port. So I2C port. So there are some registers in controller, okay, which are special purpose. So general purpose देख लिया हमने. Special purpose. अभी तुम लोगों को रजिस्टर्स पता होंगे. मैंने जो अभी बताया जनरल पर्पस. ओके, जस्ट फॉर एड्रेसिंग इट इजीली, मेमोरी लोकेशन इजीली एंड स्टोरिंग इट. बट स्पेशल पर्पस क्या होते हैं? स्पेशल पर्पस मतलब एवरी बिट ऑफ दिस रजिस्टर, every bit of this register will be known differently. Okay, every bit of this register will be known differently. Like this bit, this is R0.0, this is R0.7. Okay, now I am saying my R0 मतलब मैं जब just example ले रहा हूँ, ये कोई register नहीं है, but just to understand what is special purpose register. Okay, so एक ऐसा register जिसके हर पिन का significance अलग है. ओके, तो R0 में मैं कहूँगा कि इधर स्टेटस दिख रहा है मुझे मेरे कंट्रोलर का. इस बिट के पास एक्सेस है पावर सेविंग मोड का. ओके, इस बिट के पास एक्सेस है पावर लो मोड का. इस बिट के पास एक्सेस है स्टेटस रीड करने का. एंड ये फ्यूचर के लिए रिजर्व करके रखा है, फ्यूचर एप्लीकेशंस. तो अगर आपके पास कोई आता है बोलता है कि मुझे अपना माइक्रो कंट्रोलर पावर सेविंग मोड में डालना है, तो व्हाट यू विल डू, सपोज दिस नेम ऑफ द रजिस्टर इज R0, देन यू विल store the value in R0 wherein you are turning the power saving mode on while you know, while not changing the status of other bars. Like if everything is 0 and only this you have to you know, you are only saying I want only power saving mode, means this should be 1. Okay, so the value becomes 1 0 1 0 0 0 0 0. Okay, this value you will store in R0, and after this when you hit reset your controller will be in power saving mode. Understood what is the purpose of special purpose? This is just an example. Okay, कि रजिस्टर के हर बिट की अलग वैल्यू रहती है, हर बिट का अलग सिग्निफिकेंस होता है. तो इफ यू वांट Whenever you want, you can change those values and make your controller act according to your application. Okay, ये समझ में आ गया क्या what is special purpose register?
Yes, sir.
Okay, store the value and get the output. Then status register. Okay, store information about the current state of CPU, including flags or carry, overflow, zero, and negative conditions. Okay, so status registers. As the name suggests, status ही दिखता है उसमें. Okay, सिर्फ स्टेटस दिखता है कि क्या क्या चल रहा है. ठीक है. So एक actual register का example देता हूँ मैं. In your microcontroller, we are gonna study each register in detail. Okay, so ask everybody to attend the lecture. Okay, I don't know anything tomorrow's lecture. So I'm giving you example of PSW. PSW is program status word, I guess. Yeah, program status word. Okay, so this register has bits. Okay, that is showing us the status of the currently executing program. So there are some flags here. Okay, so if my code is having some bits where I'm doing division or multiplication, okay, or anything, okay, addition, subtraction, division, multiplication, if at all there is a suppose there is a need of a carry, okay, in subtraction, okay, so that carry flag will be set here. Okay, I mean this is just reflecting whatever is going on depending on the bits of this register. So if this is a carry flag called cy, then this will set to 1 by default. You don't change it. Okay, this is status register, right? Status means you can come down here, you can read the status of this register. Okay, you can read the status of these registers and get to know what is happening. If carry flag is set to 1, then I know arithmetic operation resulted in a carry flag. Okay, this is a small example. There are tons of things that happens which we will learn when we see each and every bits of these registers. Okay, so carry flag, then see what else current state of the CPU, then including the flag of carry, overflow, zero, or negative condition. Like whatever is the condition, not only carry. Okay, everything will be reflected over here. So is this clear to you? What is general purpose register? What is special purpose register? And what is mean by the status register? Do you guys now if I ask you, will you be able to let me know what is it? Will you be able to tell me about it? We will revise it anyways tomorrow, but at least basic things you understood, right? Hello, hello. Are you asleep?
No, sir.
No, sir.
Well, it feels like you are. So, uh, so registers हो गया. Block diagram. Let me open the syllabus. Give me a second. I'm just checking syllabus. किसी ने काम किया है कोई माइक्रो कंट्रोलर के साथ अभी कभी प्रोजेक्ट्स में और एनीवेयर? Anytime you worked on controllers? Okay, No problem.
No, sir.
Okay. So the thing is that uh, these registers, when you code, they have really huge importance. Okay, because every status value registers we need. Okay, we need most of them to calculate. We need most of them to shift data among. We need most of them to store data temporarily. So these registers are very, very, very important. I'm gonna start it from tomorrow, and I would request you guys to go back to your classmates, to your fellow colleagues, your fellow friends, your fellow classmates, batchmates, and ask them to join the classes, okay? Because after this, there is no going back. I am still, even in today's lecture, I repeated most of the things happened in the last lecture because I wanted you to understand what happened, right? But next time, like this tomorrow, this may not be the case. I may not be telling them again the block diagram, again the pin configuration, right? And the similar, I don't want to happen in the following lectures, that I'm again repeating all the registers, because we have to cover a lot of things. We have coding, we have assembly coding, we have embed C coding, we have interfacing things. Then I have to show you some simulations, how it happens and stuff. So there are a lot of things. If you cooperate well, then we will be able to cover everything, or else we just have to run in the end. That doesn't make any sense to me. So I want you guys to be there in this with me, and I want you to, follow whatever is happening during the lectures. I want you to be there in the lectures. I want you to participate in the lectures, and there is a reason behind it. Now you know that very well. So, any doubts so far, guys? Anything you have?
No, sir.
Anyone else?
No, sir.
No, sir.
Okay, then see you tomorrow. Happy weekend. Bye.
Thank you, sir.
Thank you, sir.